Bismillahirrahmanirrahim. Hello students, welcome to another video. This is Hamza Noor from Aero Education Network, and in this video I'm going to discuss a few questions from International A-Level Edexcel Mechanics M1. And in my earlier video I discussed question number 1 and question number 2 of the handout. Okay, so this is basically a series of the continuation of past paper lectures for specifically chapter number 2, constant acceleration, which is kinematics. So here we are with some more questions. First of all, we have GCE M1 January 2010, question number 2. This is question number 3 of the handout. So the question says that an athlete runs along a straight road. She starts from rest and moves with constant acceleration for 5 seconds, reaching a speed of 8 meter per second. This speed is then maintained for t seconds. She then decelerates at a constant rate until she stops. She has run a total of 500 meter in 75 seconds. So the requirement of part A is in the space below. In the paper, you would be provided with a space. So in the space below, sketch a speed time graph to illustrate the motion of the athlete. So first thing first, we are going to make a sketch of a speed time graph. Okay. So first I make the horizontal axis, then the vertical axis. All right. So time in seconds on the horizontal axis and speed v meter per second on the vertical axis, particularly speed. So the athlete starts from rest, meaning the graph will start from origin and moves with constant acceleration for 5 seconds, reaching a speed of 8 meter per second. So from the origin, the upward sloping line will start, and when time is 5 seconds, so speed is 8 meter per second. All right, so here we have an upward sloping line when the time is 5 seconds. So a speed of the athlete is 8 meter per second. All right, and what she does is she maintains this steady speed. This speed is then maintained for t seconds. Okay, so the time is now from t is equals to 5 till t is equals to 5 plus t. So here we will have a horizontal line. This speed will be maintained for a further t seconds, which will make this time over here as 5 plus t, or you can say t plus 5. T plus 5, or you can say 5 plus t, meaning this horizontal distance is basically t seconds. Okay, so when you write t plus 5 over here, so obviously this implies the fact that this time duration for the steady speed is t seconds, but t is unknown right now. And now in the last stage of the journey, what happens is that she decelerates at a constant rate until she stops. She has run a total of 500 meter in 75 seconds. So the thing is that in the last stage of the journey, when she decelerates, we don't know in how much time she is decelerating. What we know, the fact is that the journey is completed when time is 75 seconds. And as per the requirement of part A, we just need to sketch the speed time graph. We don't need to find the value of t in part A. Okay, we need to calculate the value of t in part B. So what I'm trying to explain is that in the last stage of the journey, before the calculation of the value of t in part B, we are not exactly sure right now that the last stage of the journey will have a flatter graph or a steeper graph, or it will have the same gradient as the gradient of the upward sloping line. I mean, will it have the same absolute value of the gradient as the absolute value of the gradient of the upward sloping line? Okay, we are not exactly sure before calculating the value of t. But what we can do is that we can use some common sense over here. So if you look at the scenario which is given to you in the question, the athlete runs along a straight road. Okay, obviously when an athlete runs in a marathon, in a race, so they try to achieve a maximum speed in a very less time, isn't it? Make sense or not? When the athlete starts to run in the marathon, in the race, so she tried to achieve a speed of 8 meter per second in 5 seconds as quickly as possible. And from t is equal to 0 to t is equal to 5, she was constantly accelerating until she reached a speed of 8 meter per second. All right. And then for t seconds, where the value of t is unknown, she maintains this speed. Okay, and in the last stage of the journey, she is coming to rest, meaning in the last stage of the journey, she is decelerating. Okay, so basically, she is gradually decelerating in the last stage of the journey. Obviously, when athlete has reached a maximum speed, let's say 8 meter per second, so obviously the athlete would not decelerate immediately after reaching a maximum speed, unless there is a specific case where an athlete is tired or injured. Okay, so they will try to just immediately stop and they will basically quit the race. But if the race is being continued, so athlete would be gradually decelerating in order to maintain their stamina and in order to reach their finish line of the race, they will gradually decelerate. Okay, so what I'm trying to explain is that in the last stage of the journey, the line would be flatter as compared to this line, this upward sloping line, which was a steeper line. What I'm trying to say is that the athlete would gradually decelerate. The athlete would take more time to decelerate as compared to the time which was taken to accelerate. So this is basically the common sense which we are going to deal with over here for part A. Okay. And the fact is that in the last stage of the journey, the athlete will gradually decelerate and she will reach the finish line of the race. And she will take more time to decelerate as compared to the time she took for the acceleration part of the journey. Okay, unless the athlete is injured, they have to immediately stop. In that case, the line would be very much steeper, right? Okay, this makes sense. And secondly, if you are not able to decode this common sense in this part, so no worries. You can leave this third stage of the journey right now. Okay, you can leave this third stage of the journey right now. And first you attempt part B and you find the value of t. Once you are able to find the value of t, because you know the fact that the athlete has run 500 meter in 75 seconds. So area of the trapezium would be 500. Okay. And once you are able to find the value of t, you would be able to find the value of t plus 5 as well. And then you would be immediately able to recognize that the deceleration part of the journey took a little longer as compared to the acceleration part of the journey, meaning the magnitude of the deceleration will be less than the magnitude of the acceleration. Okay, I hope you are understanding what I'm trying to say. For the last stage of the journey, if you are not sure, if you are not able to, decode this common sense of the question, no worries, no problem. Okay, just take a deep breath and first you attempt part B. All right, and find the value of t. And by that value of t, you can just be sure that how the last stage of the graph would look like. Isn't it? Make sense? It's better to be cautious than to, just immediately make a steeper line over here, or to just make the last stage of the journey having the same absolute value of the gradient as the first stage of the journey. So it's better to be cautious. But even though if you are just able to decode this common sense of the question, the whole scenario, that is absolutely perfect as well. So in this case, the last stage of journey would be, the time of deceleration would be a little longer. The last part of the journey, the last downward sloping line would be flatter. Okay. And in part B, when you will find the value of t, this thing will be 100% proven. You will be completely assured of this thing. So right now I'm making a flatter line over here. And then in part B, I would be able to prove this thing. All right. So here from t plus 5 till the end of the journey, the end of the journey is when the total time is 75 seconds. Okay. So in the last stage, line would be flatter, and the journey will end at 75 seconds over here. All right. So this was basically part A. Now let's attempt part B. We need to find the value of t, and since we know the fact that the athlete has run 500-meter in 75 seconds, okay, so area of the trapezium is 500-meter. Okay, area of trapezium is 500 basically. So I'm going to say that the total distance covered is 500. So 500 is equals to half multiplied by height multiplied by sum of parallel sides. So height is basically the perpendicular distance between the two parallel sides. So height is basically 8. Okay. And one parallel side is 75 and the other one is t. One parallel side is 75 and the other parallel side is t. Okay. So this is basically the thing. So just find the value of t. So 500 multiplied by 2 divided by 8, this will be equals to 75 plus t. So how much this is? So 500 multiplied by 2 divided by 8, this is 125. So 125 minus 75 is equals to t. So 125 minus 75, this is 50. T is equals to 50 seconds. Okay, the athlete maintained the steady speed for 50 seconds. This is the requirement of part B. You got your answer to part B. And now you can see that this time would be t plus 5, meaning 55 seconds. And the last stage of the journey, the deceleration part of the journey, will be 20 seconds because 75 minus 55 is 20. The last stage of the journey took 20 seconds. It took 20 seconds to decelerate and it took 5 seconds just to accelerate. So here I have established my point successfully. All right. In the last stage of the journey, the line would be flatter. Okay. So sometimes you need to just pick up the common sense of the question, the basic understanding of the question. But if you are not able to, immediately recognize this, so just hold on, wait for the next part, find the value of t, and then make the last stage of the journey. Okay. Instead of making any error where you just make this line steeper or with the same absolute value of the gradient as of acceleration journey. So it's better to hold on and find the value of t first in part B, and then you complete your sketch. Okay. So this was the explanation of this question. And this was basically question number 3 of the handout, January 2010, question number 2. All right, so now moving on to the next question. Here we have question number 9 of the handout, which is GCE M1 January 2012, question number 6. Okay, so the question says that a car moves along a straight horizontal road from a point A to a point B, where the distance between A and B is 885 meter. The car accelerates from rest at A to a speed of 15 meter per second at a constant rate of a meter per second square. The time for which the car accelerates is 1 over 3 into t, meaning 1/3 of t seconds. The car maintains the speed of 15 meter per second for t seconds. The car then decelerates at a constant rate of 2.5 meter per second square, stopping at point B. So the requirement of part A is to find the time for which the car decelerates. Okay, so here we have 3 stages of the journey. First one is the acceleration part of the journey. Okay, the second one is constant speed for t seconds. Okay, a constant speed of 15 meter per second for t seconds. Okay, and then the third stage of the journey is deceleration part, where the rate of deceleration is given to us in the question. So for part A, we just need to consider the deceleration part of the journey. So here I'm doing the working for part A, meaning when we are decelerating. All right. So just before deceleration, we are going with a steady speed, a constant speed of 15 meter per second for t seconds. Okay, so when deceleration basically starts, the initial speed, the initial velocity will be 15 meter per second. Make sense? And then when the deceleration rate is 2.5, so acceleration is minus 2.5. All right, acceleration will be taken as minus 2.5 meter per second square. And then the car stops at point B, meaning the final velocity will be zero, final speed will be zero, so final velocity V will be taken as zero. Okay, and what we need to find, we need to find the time for which the car decelerates. We need to find the value of t. So what we can do, we can simply use the equation v is equals to u plus at. So 0 is equals to 15 minus 2.5 times t. Okay, so t is equals to 15 divided by 2.5, meaning t is equals to 6 seconds. The value of t is basically 6. This is the answer for part A. All right. So for 6 seconds, the car decelerates. So now moving on to the next part. Part B is saying that sketch a speed time graph for the motion of the car. So we need to sketch a speed time graph. So I'm going to make the space over here, the sketch over here. First, we have the horizontal axis, time in seconds, and on the vertical axis, we have a speed, v meter per second. v meter per second is the speed, as we need a speed time graph, and this is the origin. All right, so first of all, if we look at the acceleration part of the journey, so we have started from rest and we reach a speed of 15 meter per second, and the duration for acceleration is 1/3 of t. So when time is basically t over 3, the speed is 15 meter per second. So here we have an upward sloping line. Okay, when the time is t over 3, so the speed is 15 meter per second. I'm going to make this broken horizontal line straight. Okay. And then for further t seconds, what happens is that the car maintains this constant speed. The car maintains the speed of 15 meter per second for t seconds, meaning further t seconds. Okay, so from t is equals to t over 3 and onwards, for the next t seconds, we have a horizontal line. So when you add t over 3 and t, so t plus t over 3 is 4t over 3. So when you have mentioned this thing, this time is 4t over 3 seconds. So obviously this implies the fact that this horizontal distance of the time duration is t seconds. Okay, so you can either mention in this way as well that this horizontal difference is t and this horizontal distance of time is t over 3. Okay, otherwise we have already mentioned 4t over 3, which obviously implies the fact that this 4t over 3 is obtained after adding t into t over 3. All right. And then the last stage of the journey comes where time is 6 seconds. Okay. So what we know the fact is that the deceleration part of the journey is just 6 seconds. Okay, a very less time, 6 seconds. So where the journey ends completely, the time, the total time of the journey will be 4t over 3 plus 6. All right. So what you need to understand over here is that, again, the same thing. If we look at the common sense of the question, so basically the car is starting the journey from rest and reaching a speed of 15 meter per second. And then for t seconds, the car is maintaining the speed of 15 meter per second. And the last stage of the journey is the duration is 6 seconds. Okay. So it would be a steeper line. The journey of duration the duration of basically the deceleration is just 6 seconds. Okay, now if we assume that this journey of acceleration is having a time of less than 6 seconds, if we assume this thing, okay, so this last stage of the journey would be a flatter line. This last stage would be flatter if you assume that this t over 3 value is basically below 6. Okay, so the thing which I'm trying to explain you is that again the same thing, that you are not exactly sure right now if the last stage of the journey would have a steeper line or a flatter line as compared to the acceleration stage of the journey. Okay, so one thing you can do, you can stop over here and just first attempt part C and find the value of t. Otherwise, if you just use the common sense of the question, so this 6 seconds is very less time, the duration of deceleration is just 6 seconds. And if you assume that this value of t over 3 is below 6, let's say this is 4. So the base of the triangle is 4, height is 15. So 15 times 4 is 60, 60 divided by 2 is basically 30. So this area would be just 30. Okay. And when we have the duration of 6 seconds in the deceleration journey, so base of the triangle is 6 and the height is basically 15. So 15 multiplied by 6 divided by 2, so this will be 45 meter. So the area of rectangle would be like 885 minus 30 minus 45, which will be still a very high value, which would not make much sense over here. Okay, although it can make some sense, but it would not make much sense over here. So basically 6 seconds is very less time, the deceleration part of the journey. So either you can just stop right now and find the value of t in part C first, and then you would be 100% completely sure that the last stage of the journey would have a steeper line. Okay, and this value t over 3 would be definitely more than 6. It would be more than 6, so that we would be able to get a significant area of this first triangle, and then we would have the area of rectangle, and then in the last stage the area of the triangle would be 6 into 15 divided by 2, meaning 45 meter. Okay, and then we would be practically able to say that the distance between A and B is 885 meter. Okay, so here I'm making a steeper line, and then in part C you would be able to verify this thing, that the duration of the deceleration journey is very less, just 6 seconds, as compared to this value t over 3, which we are going to obtain by finding the value of t in part C. Okay, so the last stage is just 6 seconds and line would be steeper as compared to the upward sloping line which we made. So when the journey is ending, so the total duration is 4t over 3 plus 6, which obviously implies the fact that the duration is 6 seconds over here in the deceleration part of the journey. Okay, so in part C you will be able to verify this thing what I'm trying to say. Otherwise you can just leave this last stage of the journey right now, and first you attempt part C. Okay, so first you attempt part C. Okay, so find the value of t. Since the total journey, the complete journey is having a total distance of 885 meters, so area of the trapezium is 885. So I can say that the total distance is 885 meter. So 885 will be equals to half multiplied by height multiplied by sum of parallel sides. So height of the trapezium would be 15 over here. Okay, and one parallel side is basically t seconds. Okay, one parallel side is t, and the other parallel side is 4t over 3 plus 6. As we have already done the working in part A, that the total duration of the journey is 4t over 3 plus 6. So just solve this equation and you will get the value of t. And when you divide the value of t by 3, so the value of t over 3 would obviously be more than 6 seconds. which would definitely imply the fact that the duration for acceleration part of the journey is higher than the duration of the deceleration part of the journey. Okay, if you are able to decode the common sense of the question before attempting part C, then it's totally fine. Otherwise, you know, if you feel that it is too risky, okay, to lose your mark, so you can just wait for a while and first you calmly attempt this part C. There is no issue in leaving the last downward sloping line for a while in order to be 100% sure that the last stage of the journey would have a flatter line or a steeper line. All right. So no need to be too much stressed about it. All right. So just solve this equation. So 885 multiplied by 2 divided by 15. This will be equals to what? T plus 40 over 3 is how much? 1 plus 4 over 3. This is supposed to be 7 over 3. So 70 over 3 plus 6. So 885 multiplied by 2 divided by 15. This is 118. So 118 minus 6 is equals to 70 over 3. So t is equals to 112 multiplied by 3 divided by 7. So 112 multiplied by 3 divided by 7. Value of t is 48. This is your answer to part C. And now you can completely check this thing that when the value of t is 48 seconds, so t over 3 is basically 48 divided by 3, which is 16, and duration of 16 seconds is higher than the duration of 6 seconds. So obviously, the last stage of the journey would have a steeper line. The absolute value of the gradient would be higher. The absolute value of the gradient in the last stage of the journey would be higher, meaning the magnitude of deceleration would be higher as compared to the magnitude of acceleration over here. All right, this is basically the thing. The car is taking less time to decelerate from the speed of 15 to rest. All right, so this is basically the whole concept behind this. And when you have already found the value of t, so t over 3 is 16, so you can just see that the rate of acceleration would be 15 over 16, meaning the absolute value of the gradient of this upward sloping line would be less than the absolute value of minus 2.5, meaning less than 2.5. So just put 15 over 16 in your calculator. Okay, you are getting 0.9375, meaning the absolute value of the gradient of this upward sloping line is 0.9375 of it. Obviously the positive value 0.9375, and here in the last stage the gradient is minus 2.5, meaning the absolute value of the gradient is 2.5, which is higher. Okay, so the magnitude of deceleration is higher than the magnitude of acceleration, which definitely implies that the last stage of the journey is having less time. So these are basically some important things which you don't need to ignore. All right, this was much significant detail, much significant detailed explanation over here. Okay, we have already found that here the duration is 6 seconds and here the duration is t over 3, meaning 48 over 3, meaning 16 seconds. All right, so now let's move on to the next part. So this was part C. T is equals to 48 seconds. So now let's move on to the next part. I'll bring the picture of the question on the next page. Okay. So in part D, it is being said find the value of A. Okay, which I already told you how to find. I explained this verbally. I'll bring the picture of the sketch on the next page as well. Okay, to do some further calculations. So the acceleration is 15 over 16, as I already explained verbally. We just need to show the working over here for part D in order to find the value of acceleration. Okay, because A was basically the acceleration of the first stage of the journey, right? As per the information of the question. All right, so that is basically the thing. So just put the formula Acceleration is equals to v minus u over t. Okay, here I'm attempting part D. Acceleration is equals to v minus u divided by t. So the final velocity, final speed is basically 15, initial is 0, and the time duration is t over 3, meaning 16 seconds. So 15 divided by 48 over 3, which is 15 divided by 16. So you can leave your answer in an exact form in a fraction, or you can say just 0.9375 meter per second square. So the rate of acceleration is 15 over 16 meter per second square. All right. Then in part E, we need to sketch an acceleration time graph for the motion of the car. So it's very simple. We have three stages of the journey. In the first stage, we will have a positive acceleration. In the second stage, when the speed is constant, so acceleration will be zero. And in the last stage, you will have deceleration. So the value of deceleration will be a negative value. So here I'm going to sketch the acceleration time graph. Okay. So acceleration is a vector quantity. So you make the room for a positive acceleration as well and a negative acceleration as well. So on the horizontal axis, time in seconds, this is origin. And on the vertical axis, we have acceleration meter per second square. Okay, so in the first stage, acceleration is 0.9375, which is 15 over 16. So you can write 15 over 16 as well. From t is equal to 0 to t is equals to 16 seconds, okay? Because the first stage, first part of the journey was t over 3, right? 48 over 3, meaning 16 seconds. So from t is equal to 0 to t is equals to 16 seconds, we will have a horizontal line because the acceleration is constant. Okay, so the value of acceleration is how much? 15 over 16. Okay, so let's say somewhere over here, from t is equal to 0 to t is equals to 16, acceleration is 15 over 16, meaning 0.9375. Then from t is equals to 16 to t is equals to 4t over 3, meaning the duration for the second stage is t seconds itself, and the value of t is 48. So 16 plus 48 is basically 64. So from t is equals to 16 to t is equals to 64, the acceleration will be 0. So the acceleration time graph will be on the horizontal axis itself. Okay, so here I'm going to make a horizontal line on the x-axis, on the t-axis itself, which means that acceleration is 0. And the last stage of the journey, the deceleration stage of the journey was 6 seconds. Okay, so 64 plus 6 is 70. So at 70 seconds, our journey is being completed. So 6 seconds interval is a very small interval. Okay, so visually, this should look something like this, that when this first interval is 16 seconds, so obviously this last interval should be just 6 seconds. You don't need to make 70 over here like this or like this. Okay, you need to make sure of these important things. All right, they are very important for your accuracy marks and independent marks. So the last stage of the journey has having is having an acceleration of minus 2.5 because the rate of deceleration was 2.5, so acceleration is minus 2.5. So now you need to make sure that when on the vertical axis you have this much distance for 0.9375, meaning this much distance for 15 over 16, so you would have a higher distance below the horizontal axis for minus 2.5. Okay, so you need to be sure of these things. So here I'm going to write minus 2.5, which looks much better. Okay, the distance from the horizontal axis till 15 over 16 is small, and distance from the horizontal axis till minus 2.5 is higher. Okay, so I'm going to just use my scale and bring the horizontal broken line over here, and I just need to make from t is equals to 64 to t is equals to 70. Okay, So I'll just use this blue pen till 64, from t is equals to 64 to t is equals to 70. In order to be sure of all the accuracies, I need to just erase a little bit part. Okay, so this is basically the last question of this video, and I'll be making more videos, inshallah, and stay tuned to my channel. Okay, so just make a vertical broken line over here as well. All right, just make a vertical broken line over here as well, and you can make here as well, and you can just show that. I mean, this horizontal broken line is not very much important, but just try to make the vertical lines at least. Okay, because there is abrupt changes in the values of the graph. Okay, when t is equals to 16, so basically the first stage of the journey is ending. Okay, in the first stage acceleration is 15 over 16, and then is steady speed, so acceleration is 0, and then in the last stage deceleration starts, so acceleration is minus 2.5. Okay, so this is basically the acceleration time graph for part E. All right, so this was basically the question number 9 of this handout, which is GCE M1 January 2012, January 2012, question number 6. So for the purpose of this video, I have recorded 2 questions. Okay, inshallah, I'll see you in my next video. Stay tuned to my channel. More content is coming. So thanks for watching. And if you have any queries specifically for A-level mathematics, Cambridge or Edexcel, any of the components, okay, so you can contact on my WhatsApp number as well. I would be more than happy to help as soon as I'm free. So stay tuned. Thanks for watching. Happy learning. Assalamu alaikum.